Alright, last problem here. The force of acceleration due to gravity on Earth is negative 9.8 meters per second squared. So A of t equals negative 9.8. Let's integrate that to get v of t, our velocity function, is negative 9.8 t plus v naught. And our height function, h of t, equals negative 9, boo, I'm bad at math, negative 4.9 t squared plus v naught t plus h naught. And we're told that let's read the problem real quick. With what velocity would you need to throw a Nerf football straight up with in order to reach a maximum height of 30 feet if you release it 6 feet above the ground? That 6 feet is telling us our starting height. So we have these equations right here. What do we know? We know when that Nerf ball reaches its maximum height, the velocity is 0. So I'm going to say 0 equals negative 9.8 t plus v naught, setting my velocity function equal to 0. That then implies that that t value is the time it takes to reach the maximum height. And I can then say that h of t, the maximum height of 30, equals my height function, negative 4.9 t squared plus v naught t plus 6. And now I can rewrite this velocity equation as 9.8 t equals v naught, and I can substitute that in for v naught right there. So 30 equals negative 4.9 t squared plus v naught is 9.8 t. I'm multiplying that by t, so I get t squared. Then I have plus 6 right there. So negative 4.9 t squared plus 9.8 t squared gives me 30. Let's actually subtract that 6 over to get 24 equals positive 4.9 t squared. And so then 24 over 4.9 equals t squared. So t equals the square root of 24 divided by 4.9. Which means it takes roughly 2.213 seconds to reach that maximum height of 30 feet. And we want to know what's the velocity it takes. So now we're plugging into this equation to get 9.8 times that time, 2.213, equals our v naught. And so v naught equals roughly 21.689 meters per second.